Good afternoon to all of you. My name is Nitin Tomar and I am a third year PhD student in the Department of Mathematics at IIT Bombay. Today in this session we are going to discuss some problems from complex analysis. Okay, and I welcome you all. So, oh, you can see two of me by shared screen. So, is the screen visible to all of you?
Yes, sir. Visible.
Yes, sir.
So, today I want to just start with one result because we have done logarithm and we have spent some enough time. So, do you have any doubts in that? Hmm? Any one of you? Okay.
Yes,
Yes,
sir.
sir.
Capital
Capital
logarithm
logarithm
means
means a
principal
principal
log
log
can be
can be
extended
extended
to
to
continuous
continuous
function on
function
C
on C
star.
star.
No. No, no, no. Okay, let me write that question. So we call if given z in c minus 0, we have seen that this function log z, which is defined as ln mod z plus iota exponential of principal argument of z, right? This we saw in the last class, and this is called the
Sir,
Sir,
I
I
argument Z
argument Z
नहीं
नहीं
होगा.
होगा.
oh, no, no,
Plus
Plus
I
I
e to
e
the
to the
power
power
कैसे
कैसे
होगा?
होगा?
sorry, e I argument. No, am I doing something wrong?
Yes,
Yes,
logs
So
logs
modulus of
modulus of
Z
Z
plus
plus
plus iota,
I
I
theta.
theta.
yeah,
Argument
Argument
Z.
Z.
yes, yes, yes. And this was called as principal branch of logarithm, right? Not a principal branch of logarithm, not branch now. It's not a branch. So we saw that this function is actually single valued, right?
Yes,
Yes,
sir.
sir.
And we saw that this is not continuous. So this was first step, but not continuous
Continuous.
Continuous.
on c minus 0. Okay. So for continuity, what did we do? For continuity, what did we do?
We
We
remove
remove
Z
C
minus
minus
both of
x-axis.
x-axis.
Exactly. So first, our domain was this, right? This was omega. But then we took another domain, let's say omega 1, which is c minus infinity to, we remove this negative axis, right?
Yes, sir. Yes, sir.
And this is a subset of omega. Now on, and so this is a domain. So in the domain, we have seen that in the domain omega 1, this principal branch of log z is actually holomorphic, right? Not only continuous, we saw that this is holomorphic, and its derivative, complex derivative, was 1 by z. We finished here, right? Darshana, Thangeshwaran.
Yes,
Yes,
sir.
sir. Yes,
So,
sir.
do you have any doubts up until now in this part?
No,
No,
sir.
sir.
Hmm. Okay. So I just want to prove one more theorem about this. Then we will move to Picard's little theorem. Okay. Yeah. So this is the theorem, and we have seen that, like, instead of removing one negative axis, you can remove any ray including zero, right? This we have also discussed. So the theorem is, if G is a domain in C, and F is a branch of logarithm, this is a branch of logarithm. What do we mean by that? Can anyone tell?
Exponential
Exponential
f z
f z
is
is
z.
z.
Very good. For all Z in
C.
G.
C.
G.
G.
Right?
G.
हाँ.
हाँ.
Then any other branch of logarithm, this with respect to G, okay, let me first write, then I'll explain. With respect to G is of the form fz plus 2k pi iota for some k in integer. So what does this theorem is trying to say? That given, if you have a given branch, okay, if you have given f a holomorphic function, right? A branch of logarithm, we have proved that it is a holomorphic function, correct?
Yes,
Yes,
sir.
sir.
Such that e power fz is z. This is what we mean by branch of logarithm, correct,
Yes, sir.
Thangeshwaran?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Now the question is, now the question is, can we find every g from G to C, holomorphic of course, holomorphic, such that e power gz is z. Can we do that? Is the question clear? Is the question clear?
Yes, sir.
Yes, sir.
Hmm. So, one such possibility is fz, right? Because it is given e power fz is z for all z in G, correct? You people seem confused. Do you have any doubt in this question?
No,
No,
sir.
sir.
Hmm. So let gz be one such function, okay? Gz be one. So from here the proof starts. Gz be one such function on G, capital G. Then can we say e power fz is same as e power gz? Can we say that they both are
No,
No,
sir.
equal
sir.
to Z, right?
Ah,
Yes.
yes.
Yeah. Now what does it imply? E power fz
Minus
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 Z.
GZ.
gz is 0.
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir.
and this is for z in omega, for z in g, for z in g. Now are we done? Can I write gz equal to fz plus 2k pi I?
No,
No,
sir.
sir.
Why?
Minus
Minus
infinity
infinity
not
not
in
in
G.
G.
Hmm? Sorry.
Yes,
Yes,
sir.
sir.
Minus
Minus
infinity
infinity
not in
not in
G,
G,
sir.
sir.
No, you don't know anything about the domain. Okay. For some k, I am saying. For some k.
Okay, sir.
Okay, sir.
See, when is EW is 0? When W is a multiple of 2k pi I, right? When W is a multiple of 2 pi iota, only then. Oh, sorry. Oh, here it should be 1. Sorry. Here it should be 1. Yeah, sorry. Yeah. EW is 1 when W is a
Uh,
multiple of 2 pi
now,
iota.
now,
If
now
Now
clear, sir.
clear, sir.
yeah. Now can we write?
Yes, sir.
Yes, sir.
Okay. Still, see, there is a gap in the proof. You know this? Okay. This k that we have written here, right? This k depends on z, right? Yes or no? See, all these these three equations holds. First, you fix some z, right? Are you getting what I'm trying to say? See, e power fz is equal to egz. So you must have started with some given z in g, right? Now, what do we mean by this? Then e power fz minus gz is 1. So this fz minus gz, it should be some multiple of 2 pi iota, right? But this multiple k, it depends on z. You will change your z, this k will change, right? Let's say for z1 it is k1, for some z2 it will be some k2, correct?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So actually, okay, now I think you have got it. So actually, so how we should write it as, this should be written as fz is equal to gz plus 2 pi iota times k of z, right? Because it is a function of k, correct? Now it is correct. Do you all agree?
Yes,
Yes,
sir.
sir.
Hmm. So this kz is what? F, gz minus fz. See, this is a very important result, and since we have done logarithm, I just wanted to do for all z in g, right? This all you agree? I have just shifted.
Yes,
Yes,
sir.
sir.
Yeah. Now, is k a continuous function? K is a function of what? J2. What are the values of k? This k was integer valued, right?
Yes, it
Yes,
is
it is
continuous
continuous
function.
function.
And it is integer valued, right?
Yes.
Yes.
So now G is a domain, right? So K of G must be connected. Continuous image of a connected set is connected. Do you all agree? G is a domain, so therefore G is connected. So K of G, which is a continuous function, so continuous image of a connected set is always connected. So K of G must be connected, right?
Yes,
Yes,
sir.
sir.
Hmm.
Yes.
Hmm.
What about the others?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now,
Yes,
so
sir.
connected in what? Connected in Z, right? Now, what are the connected set in Z? Singletons? Only singletons
Yes,
are
yes, sir.
connected.
Yes.
So this implies this implies k is a constant function, right? Because this implies k of g must be some singleton c, or for better we use m. So do all of you agree with this? Do you have some doubt?
No,
No,
sir.
sir.
Hmm.
No, sir.
No, sir. So finally now we have what we wanted, right? This kz, which at first glance it seemed like, oh, it is a function of z, but continuity and connectedness say that this is a function but it is a constant function. Okay, so gz is fz plus 2 pi iota times m, where m is this k of z. Okay, and this holds for every z in g, and this is precisely what we wanted to prove. Correct? So any other branch, if you have one branch of logarithm, then any other branch is just a translation. Okay, does this sound
Yes, sir.
good to you? Okay.
अच्छा, वो
अच्छा, वो
extension
extension
वाला.
वाला.
Huh? Yeah. Darshana, what was the doubt?
1 minute,
1 minute,
sir.
sir.
वो
वो
आगे.
आगे.
हाँ, yes.
Yes.
Log can be
Log can be
extended to
extended to
continuous
continuous
function on
function
C
on C
star.
star.
No. We saw na what was the problem? The problem was this complete axis. This ray, this lines ray was the problem. We saw in the last lecture that on this line it was not even continuous.
Yes, sir.
Yes, sir.
Log is single valued on C star. Okay, it is a function on C star, but it is not a continuous function on C star. Okay,
Okay, sir.
Okay, sir.
because we saw na via sequential criteria, we consider these two sequences, right? And here the limit was pi, and here the limit was minus pi. Correct?
Yes.
Yes.
Yeah. So the continuity fails. Do not bother about holomorphicity. It's not even continuous. Okay. Do you all agree?
Yes, sir.
Yes, sir. Hmm. Okay. Let's move to Picard's theorem. Do you know little Picard's theorem?
Yes, sir.
Yes, sir.
Okay. I will write a statement. So what does it say? First of all, it's a statement about entire functions, right? It says if an entire function omits 2 points in its range, then it is constant. Correct? Yes or no? Am I audible?
Yes, sir.
Yes, sir.
So is the statement correct? So, yes, sir. Can you give me one example of an entire? So it says if an entire function skips more than one point, then it has to be constant, right? Now, can you give me an example of an entire function which skips only one point? Can you
F z
give
equal
me
to 1
1
upon z
upon z
minus
minus
1.
1? An entire function, such an entire. So I want an example of an entire function f such that f of c omits exactly one point. Exactly one point. Can you do that?
F z
F z
equal to
equal
1
to
by
1 by
z.
z. F z equal to, is it an entire function? This is not an entire function, right? It's not holomorphic at 0.
At
At
0,
0,
that's
that's
a
also
1
1
point.
point. No, no, but you need entire function, right? It is not an entire function. Is it holomorphic at 0?
No, sir.
No, sir. What is the definition of entire function? A function which is complex differentiable at every point.
Sir, e
3
power
per
z.
z. Yes, exactly. So this is not correct. Okay, Darshana, is the confusion clear?
Yes,
Yes,
sir.
sir. E power z. What point does it skip? F of c is actually c minus 0, right?
Yes, sir.
Yes, sir. Hmm. Okay. Now, can you give me an example of entire function which skips exactly 2 points? These are very easy questions. An entire function, an entire function which omits exactly 2 points. Can we do that? Do we have an example? Read the statement of Little Picard's theorem. Do you know what does omit mean? Is the statement clear to all of you? If not, then please ask. I am not expecting that okay you will be knowing this. Okay, so you can ask very freely. Okay, let me explain diagrammatically. Okay, you have an entire function. Entire function means it is defined everywhere on the complex plane, and not only that, it is holomorphic. Okay, it is holomorphic. This is what we mean by entire function. All of you agree?
Yes, sir.
Yes, sir. Yeah. Now, so this is my entire function definition. Now, how do you define range? What is range of this function? By definition, range of function is denoted by f, range f. So this is first, this is second. How do you denote it? How do you write it?
F
All
of
those, what
f
are
of
the
c.
values taken by f, right?
Okay, sir.
Okay, sir.
F of
F of
c
c
also.
also. Yeah. Yes, basically f of c, right? This set. Now, what does Picard theorem says? Picard theorem says, or this is Little Picard. So, Little Picard theorem, what does it say? That f of c, this range set cannot be C minus some A1 A2, or C minus A1 A2 A3, and so on. Now do you get it? So in the range you cannot have more than 2 points lost. Okay, diagrammatically the range of entire function cannot have more than one whole. Okay, let's say this is A1, this is A2. No, it cannot happen. Is this clear? Now is it clear, the statement of Picard's theorem?
Yes,
Yes,
sir.
sir.
Now you answer this question. Yes, Manak? Yes. Do you have doubt? Hello Manak, we can hear you. Oh, okay. 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 So what is the entire function which omits exactly 2 points? Do we have such function? So what do we want? What do we want here? We want our f of c to be something of this form: c minus a1 a2, right? 2 points. You kill 2 points. But is this possible?
No,
No,
sir.
sir.
No. Why? We just saw. Little Picard's theorem say in the range.
Earth theory.
Theory. Yeah. So like imagine like this. You all like hunting, huh? Like it's very fancy, right? I mean, not but you must have seen people hunting, killing with gun, right? So Little Picard's theorem says that you can only shoot one person, kind of a thing. At the most, you can shoot only one person. You cannot shoot more than one person. It's a very bad parallel, but it is what it is. So in this third part, what is it trying to say? You have to shoot 2 points, right? But can we shoot 2 points?
Non
Non-constant
constant entire
entire
function है
function
तो.
है तो.
You can, Darshana.
Yes.
Yes.
इसमें
इसमें
ऐसा है
ऐसा है ना
नॉन
नॉन
कांस्टेंट
कांस्टेंट
एंटायर
entire
फंक्शन.
function.
नहीं देखो, अगर कांस्टेंट होगा तो कांस्टेंट में तो एक ही पॉइंट आता है. मुझे चाहिए एग्जैक्टली 2 पॉइंट्स.
ओके.
Okay.
कांस्टेंट में तो एक से ज्यादा सब छूट जाता है ना. मुझे कितने पॉइंट्स छोड़ने हैं? बस 2 पॉइंट्स छोड़ने हैं.
ओके.
Okay.
तो पिकार्ड थ्योरम क्या कहती है कि तुम ज्यादा से ज्यादा एक पॉइंट छोड़ सकते हो, एक से ज्यादा नहीं छोड़ सकते.
सर
सर
लॉग जेट हो
लॉन्गजेट हो
सकता है
सकता है
क्या?
क्या?
बच्चे, लॉग जेड एंटायर फंक्शन नहीं है ना. पहले ये चीज क्लियर रखो दिमाग में कि तुमको एंटायर फंक्शन चाहिए. लॉग जेड तो हर जगह होलोमॉर्फिक ही नहीं होता. तुमको चाहिए हर
हाँ
जगह
हाँ.
होलोमॉर्फिक. दर्शना भी यही गलती कर रही थी अभी. मैनिक, इज दिस क्लियर टू यू?
यस.
Yes.
Okay, I don't think it is clear to. I mean, you people are blank today. Okay. So first of all, you need an entire function. What is an entire function? Which is holomorphic, right? On C. So if this is my complex plane, then f is a function from C to C, right? Does the diagram make sense to you, all of you?
यस
Yes,
सर.
sir.
Now listen very carefully. Little Picard theorem says you can skip only one point at the most. You can, so range cannot be like, you cannot skip this point and this point. Okay, this is not possible. You cannot skip more than one point in the range. For we have seen, for example, for Ez we can skip one point, right? This 0 point we can skip. But if I were to ask you, can you skip 0 and 1? Can you skip 0 and 1? What will be your answer?
Constant
Constant
function.
function.
Okay, but if I ask you exactly 0 and 1, exactly 0 and 1 means in the range I want everything except 0 and 1. Okay, this theorem is very simple. What part is not clear to you? You people seem very confused today. What happened?
सर
सर
गिव
गिव
वन
वन
एग्जांपल
एग्जांपल जिसमें
जिसमें दो
दो
पॉइंट
पॉइंट
ओमिट
ओमिट
होते हो.
होते हो.
ऐसा एग्जाम्पल नहीं होगा ना, मैं यही तो बताना चाह रहा हूँ.
अच्छा.
अच्छा.
लिटिल पिकार्ड थ्योरम क्या कह रही है कि ऐसा एंटायर फंक्शन नहीं हो सकता जिसमें एक से ज्यादा पॉइंट उसकी रेंज में ना हो. Okay, you people don't even know entire functions. That way also you are confused.
नहीं
नहीं
सर
सर
एंटायर
एंटायर
फंक्शंस
फंक्शंस
तो
तो
पता
पता
है कि
है कि
पूरे
पूरे
प्लेन में
प्लेन
वो
में वो
होलोमॉर्फिक है.
होलोमॉर्फिक है.
हाँ, okay. So, for example, what is the range of this function? What is
C.
the range? The complete C, right?
यस.
Yes.
What is the range? So it does not skip any point. It does not omit any point in the range, right?
यस
Yes
सर.
sir.
हाँ.
हाँ.
Yeah. Now, second, EZ.
जीरो
जीरो
स्किप
स्किप
होता
होता
है.
है.
सी
C
माइनस
माइनस
जीरो
जीरो
रेंज.
रेंज.
See, so it skips one point. Now my question is, can we have f of c, some fz entire, some entire function? I want some entire function such that f is exactly 0 comma 1. No, I don't want an example because it won't exist. I just want you to apply Little Picard's theorem. You just read this statement. If an entire function omits 2 points in its range, then it is constant.
यस
Yes
सर.
sir.
So what do I want? So I want an entire function such that it is omitting exactly 2 points, right? So Little Picard theorem will say, what will Little Picard say? That f is constant, right? Yes or no?
यस
Yes
सर.
sir. Yes sir. Yes sir.
But what is the range of constant function? It is singleton, right?
Yes sir. Yes sir. Yes sir.
So such an entire function which skips exactly 2 points does not exist, correct? Because
Yes sir. Yes sir.
this is not equal
Yes
to
sir.
what we want. Now is this clear to all of you?
Yes sir. Yes clear sir.
यस
Yes
सर.
sir.
Now again I am writing one question. Okay, you tell me. Does there exist an entire function which skips or which omits integer values, for example? What should be your answer? So okay, I'll write line by line. Okay, I know because this is new for you, so I'll write line by line. Okay. So let if possible such a function exists. Let if possible such a function exists. Now what do we mean by it? That is, there is a f from C to C entire, correct? Yes or no?
Yes,
Yes,
sir.
sir.
such that what is f of c? F of c is exactly c minus, it does not want integer value, so which means it does not want plus minus 1 plus minus 2 and 0 also. Okay, let it possible this function exist. Now since f omits more than 2 points, right?
Then
It,
it is constant function, sir.
yes, and it is entire, and f is entire. So little Picard implies, little Picard's theorem imply f is a constant function, correct?
Yes, sir.
Yes, sir. Now, but if f is a constant function, so this implies the range will be
Single
Single
digit,
digit.
sir.
some z naught, right? And this is not equal to what we want, right? This is a contradiction, yes or no?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So why this is a contradiction? Because we have assumed that such a function exists, right?
Yes, sir.
Okay, sir.
See, contradiction comes because you have assumed some wrong thing, right? So this implies the assumption is false. The assumption is false. And what was the assumption? The assumption was that there is an f entire function, there is an entire function which skips integer values. So which means assumption is false means there is no entire function which omits 0 plus minus 1 blah blah blah. Is this clear to all of you now?
Yes,
Yes,
sir.
sir. Sure? Because I will ask
Sure.
another question. Now this question is from assignment. Okay. Now does there exists a non-constant function such that non non-constant entire function, sorry, non-constant entire function f equal to u plus iota v, that's how we denote, such that u is never equal to v, or such that uz is never equal to vz. This holds for every z in C. Now what can you say about this? So again, okay, let if possible such a function exists. Okay. Now I'm going to ask some question. Okay. Does 1 plus iota this belongs to range? Does 1 plus iota belong to the range of f?
No,
No,
sir.
sir. No, right? Why?
U is
U is
equal to
equal to
V.
v. Because u is equal to v, right?
Yes.
Yes. Does 2 plus 2 iota belongs to the range? Again, no, right?
Yes, sir.
Hmm.
So, because, so what does Picard theorem will say?
F is
F is
constant.
constant.
F is constant, right? but we have to get a non-constant function, so we cannot get that, right?
Yes,
Yes,
sir.
sir.
So the answer to this question is no. Is this clear? Why?
Contradiction है
Contradiction है
ना?
ना?
Contradiction, yes. Contradiction to what? Contradiction to the fact that in the question we have been given that it is a non-constant function. Okay. Now again, so is this question clear?
Yes,
Yes,
sir.
sir.
Now, okay, now I'm going to ask another question. This is again from assignment. Does there exist a non-constant entire function, a non-constant entire function? Sir, I have many questions, please help me to solve this. Okay, Pyle, this is the last question of today anyway, so let me just finish this, then I'll come to your doubts. Is this fine?
Okay, okay, sir.
So read the question very carefully, huh, you guys. So what does it say?
Wrong है
Wrong है,
sir.
sir.
Why?
Statement.
नहीं, wrong नहीं, you should say no, right? That there does not
हाँ,
exist.
Wrong
wrong
here.
here.
हाँ,
हाँ,
no.
no.
Why?
Because
Because
if
if
I
I
take
take
x
x
equal to
equal to
0,
0,
so
so
I
I
does
does
not
not
belongs to
belongs to
a range of
range of
C,
C,
F,
F,
and
and
2i
Okay, so
is
y
you're
is
also
also
not
saying
not
belongs
belongs
to
to
I.
I
I
and
and
2i.
2i.
Okay, I and 2I. Correct. This does not belongs to the range, right? Is it?
Yes.
Yes.
But
But
sir,
sir,
I
I
have
have
one
one
doubt
doubt
of
of
this
this
type of
type of
question.
question.
No, no, Darshana, let it finish. Huh? Let this question finish. Don't hurry.
Okay,
Okay,
okay.
okay.
Does there exist a non-constant function whose imaginary part never takes value 0? Do all of you understand the question? Thangeshwaran, Payal, Ravi.
Yes, sir. Yes, sir.
Does iota belong to, if okay, let us, this creates confusion. Okay, that is why I don't like writing mathematics adha adhura. You should write like as it is. Let if possible there is a non constant entire function. There is a non constant entire function f equal to u plus iota v, such that this vz is never 0. Okay, so vz is never 0. So no, iota may or may not belong to, na Darshana. That was why I deleted that. Does 1 belongs to the range of f of c? What is the imaginary part of 1? Why is this
One.
taking? Does 1
It's
belong?
fine. Fine.
One.
I
Exactly. 1 does not
fine.
belong, right? Because imaginary part of 1 is 0, and this entire function does not take any value which has non-zero imaginary part.
Okay,
Okay,
sir,
sir,
I
I
read
read
UZ
UZ
real
real
part,
part.
Oh,
and that's
okay.
why
That's why I.
Okay, okay. Oh, sorry. I am such a terrible uh, writer. Okay. Is this clear now somehow?
Yes,
Yes,
sir.
sir.
And similarly, does 2 belongs to f of c? Does
No,
2
sir.
belong? No, right? So
No,
again,
sir.
using same logic, f is constant, right? So it is a why? Because you have little Picard theorem. F is constant, and this is a contradiction. So no such function exists. Okay. Hmm. Okay. Now I want to. Yes. Do you have any doubts now?
Sir,
Sir,
if there
if there
exists
exists
non-constant
non-constant
entire
entire
function
function
Mm-hmm.
which is
which is
bounded
bounded
on
on
both
both
real
real
axis and
axis and
imaginary
imaginary
axis.
axis.
Mm-hmm.
Yeah,
Yeah,
bounded on
bounded on
real
real
axis.
axis.
Mm-hmm. Okay. Okay. So okay. So Darshana is asking.
Please
Just
repeat again
Again,
from
from the
last
last
one.
one.
sorry.
Last
Last
question
question
একবার
একবার
বলুন.
বলুন.
Question number 3.
Yes,
Yes,
sir.
sir.
Okay. 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 So in the question was, does there exist a non-constant entire function whose imaginary part, this is v is the imaginary part, whose imaginary part never takes value 0? Is the question clear, Payal? Now I'll go to the solution. Is the question clear
Yes,
first
sir.
of all? Okay. So let us assume that such a function exists. Okay. Let us assume that there is a non-constant entire function whose imaginary part never takes value 0. Okay. Now, what can you say about what can so 1 does not belongs to its range, right? Because what is the imaginary part of 1? It is 0. 1 you can write it as 1 plus iota times 0. So its imaginary part is 0. If some f of z is 1, then uz is plus iota vz, then for that z, vz is 0, correct?
Yes,
Yes,
sir.
sir.
But what do we have? Vz is never 0. So fz is never 1. So 1 does not belongs to the range. Is this clear?
Yes,
Yes,
sir.
sir.
Now, does 2 belongs to the range of f? In fact, what in this
No,
part,
sir.
okay, let me write it
2
very.
2
plus
plus
I
I
0.
zero.
Yeah, okay. In this part, what we can say, for n, if x belongs to R, then x does not belongs to the range. Why? Because if x belongs to f of c, what does it mean? That there exists some z naught, right? Some z in c such that f of z is c, f of z is x, right?
V of z not
But this will imply v of z is 0. And this is a contradiction. Pile, is this clear now?
Yes,
Yes,
sir.
sir.
So because it is skipping, it is omitting every real point, every real number. So little Picard says कि 2 पॉइंट छोड़ते ही कांस्टेंट हो जाएगा. तो ये तो पूरा का पूरा रियल लाइन छोड़ रहा है, तो it has to be constant. Okay. Okay. Now Darshana, let me write down your question.
There
There
exists
exists
No, I heard it. I heard it. Does there exist? Does there exists an entire function f such that real part of f is bounded, right?
yes.
yes.
This is the question, correct?
Yes,
Yes,
sir.
sir.
So which means, see, f of, see this m plus 1, m plus 2, they cannot belong to f, range of f, right? Because
Yes,
Yes,
sir.
sir.
if f of z is m plus, let's say, some n for natural number, then what is real part of f? It is m plus n, or m, obviously it has to be positive, m plus n only. So its mod will be this, but this is positive number, so it will be m plus n. So if this were to happen, then we know with this inequality m plus n will be less than m, which is a contradiction, right? Okay.
बट
बट
सर ये
सर ये
लेस
लेस
देन और
देन और
इक्वल टू
इक्वल टू
एम
एम
कैसे लिख
कैसे लिख
सकते
सकते
हैं?
हैं?
एम
एम
प्लस
प्लस
एन
एन
लेस
लेस
देन और
देन और
इक्वल टू
इक्वल टू
एम।
एम।
अगर हम मान रहे हैं कि ऐसा फंक्शन एग्जिस्ट कर रहा है, तब तो लिख सकते हैं ना।
अच्छा।
अच्छा।
बात तो वही है ना। अगर हम मान रहे हैं कि ऐसा एंटायर फंक्शन एग्जिस्ट करेगा, तब m प्लस वन और m प्लस टू उसकी रेंज में नहीं आ सकते, करेक्ट? देखो,
यस
यस
सर।
सर।
जिमेट्रिकली सोचो। ये है u एक्सिस, ये है v एक्सिस, ओके। f क्या होता है? u प्लस i पर v होता है ना।
यस।
यस।
नाउ व्हाट यू आर सेइंग इन दिस क्वेश्चन, mod u इज लेस देन इक्वल टू m, करेक्ट?
यस
यस
सर।
सर।
so what so if some so this is my m and this will be my minus m, correct? So what you are precisely asking to stay in this region. In this region only this mod is less than 1 of u or not? u क्या है?
यस
रियल पार्ट है।
हाँ,
हाँ,
ये
ये
इसके
इसके
बाहर का
बाहर का
पोर्शन
पोर्शन
है।
है।
इसके बाहर का पोर्शन तो छूट रहा है ना रेंज में।
हाँ
अब
हाँ,
इतना सारा
इसके जो
पोर्शन,
अंदर का, अंदर जो
अंदर
है
जो है
ग्रीन
ग्रीन
लाइन
लाइन
वो।
वो।
हाँ, ये रीजन वो है जब mod u इज लेस देन इक्वल टू m, करेक्ट?
यस।
यस।
तो तुमको अगर ये इनइक्वालिटी सेटिस्फाई करनी है तो तुमको इस एरिया में रहना पड़ेगा, लेकिन इस एरिया में रहने के लिए तुमको काफी सारे पॉइंट छोड़ने पड़ रहे हैं।
हाँ
हाँ,
यस।
यस।
तो लिटिल पिकार्ड से क्या होगा? वो तो कांस्टेंट हो जाएगा ना।
हाँ।
हाँ।
तो द ओनली कांस्टेंट फंक्शंस विल हैव दिस प्रॉपर्टी, ओके? इज दिस
अच्छा,
क्लियर
तो
टू
ऐसा
यू?
फंक्शन, ऐसा
ऐसा
फंक्शन
फंक्शन
नहीं है
नहीं
ना?
है ना।
नहीं, कांस्टेंट तो है। कांस्टेंट अगर तुम कैपिटल M चुन लोगी तो होगा ना।
हाँ।
हाँ।
नॉन कांस्टेंट एंटायर फंक्शन नहीं है।
नहीं
नहीं
सर,
सर,
इसका
इसका
आंसर क्या
आंसर क्या
होगा
होगा?
बट?
बट
अगर इसका आंसर अगर यहाँ नॉन कांस्टेंट लिखोगे तो नो होगा, और अगर नॉन कांस्टेंट है तो नो होगा। और अगर इन जनरल आंसर होगा कि देयर विल बी अ द ओनली पॉसिबल चॉइस इज कांस्टेंट फंक्शंस, ओके?
ओके। और
और
अगर सर
अगर सर
बाउंडेड
बाउंडेड
दोनों में
दोनों
है,
में है,
रियल और
रियल और
इमेजिनरी
इमेजिनरी
पार्ट में,
पार्ट
तो
में, तो
उसमें भी
उसमें भी
यही
यही
होगा?
होगा।
दर्शना, खुद सोचो ना, जब एक कंडीशन डालने पे तुमको नहीं मिल रहा तो तुम एक और डाल रही हो, वो तो और ज्यादा रिस्ट्रिक्ट करेगा ना।
हाँ
हाँ,
वही
वही
है।
तब तुम्हें
तो
स्क्वायर में रहना पड़ेगा।
रेक्टेंगल
रेक्टेंगल
पोर्शन
पोर्शन
आएगा ना
आएगा ना
सर?
सर।
स्क्वायर, हाँ, रेक्टेंगल में
हाँ,
रहना पड़ेगा।
रेक्टेंगल
रेक्टेंगल
पोर्शन
पोर्शन
आएगा,
आएगा,
यस।
यस।
ठीक है।
हाँ।
हाँ।
यस पायल, व्हाट आर योर डाउट्स? पायल, पायल, आर यू देयर?
हेलो
हेलो
सर।
सर।
हाँ, यस, यस, यू आर ऑडिबल, प्लीज से योर डाउट्स। हेलो। Payal, actually I'm right. If since I think you have some network connection issue, This is my Gmail ID, Pile. You can share it to me and we can discuss that later. Is that fine, Pile? If you have some personal doubts, all of you, then you can always write to my Gmail ID. For example, Thangeshwaran and I, sometimes we do discuss, right, Thangeshwaran?
Yes,
Okay.
sir.
Yeah. Pile, did you receive the Gmail ID?
Sir,
Yes. So you share that PDF to me on Gmail and we will discuss. Okay? Don't worry.
Sir, I
Sir,
have
I have
also
also
one
one
doubt.
doubt.
Darshana. Yes.
Sir,
Sir,
f
f
and
and
g are
g are
entire
entire
function
function
such
such
that
that
e
e
raised to
raised to
fz
fz
plus e
plus e
raised to
raised to
gz
gz
is
is
equal to
equal to
1.
1.
Just let me write it. Question number. Can you tell me the question number? Fifth. F and G.
F
f
and
and
g
g
are
are
entire
entire
function
function
such
such
that
that
Sir,
e
what is
raised
the
to
e raised
fz
sequence?
to
such
such
that
that
e
e
raised to
raised to
fz
fz
plus
plus
e
e
raised to
raised to
gz
gz.
Darshana, can you hold? Like my phone is coming. Okay, just a minute. Huh?